let us find the center of mass of a right circular solid cone which has a height h and radius is r and its mass is m. So over here we have kept this right circular solid cone and we know that its center of mass is going to be on the axis of symmetry. So this is the axis of symmetry. So over here this is x-axis, this is y-axis, and we intend to find xcm. We know this is xcm is integral x dm over integral dm. So what we do over here is, at a distance x, we cut a small section of thickness dx. This section, when it is taken out, then it's obviously a disk only of radius y, and this is like a cylinder which has a radius y and thickness is dx. So this disk has a differential element of mass dm and it has also a differential element of volume. So its differential volume is dv and its differential mass is dm. Over here we also see that is y by x is equal to r by h, that is y by x is equal to r by h, that is theta, that tan theta is same. That is this smaller triangle and the bigger triangle, they are similar triangles. So that's why tan theta is equal to y by x is also equal to r by h. So now how we intend to proceed is, primarily our aim is to find the dm of this, of a general disk which is at a distance x and which has thickness dx. Its radii, because this is continuously changing, so y is radius of this disk will be changing. We have taken a general disk at a distance x, its thickness is dx and its radius is y. We find the volume of this disk, then we find the dm of this disk, because mass is equal to volume into density. Using that formula we'll find its mass, and then certainly when we find the dm, then we can integrate this x dm 0 to h and integral dm 0 to h. So density, we say density is mass by volume, mass is m, and volume of right circular cone is pi r square h by 3, and we say that is mass is equal to volume into density, that is m is equal to v into rho, where rho stands for the density of the material. dm is, that is mass of this is what? It is volume into density. What is volume? Volume of this cylinder is pi y square, that is area, into thickness, that is height. It is dx. So pi y square dx, so that stands for the dv, that stands for the differential volume of this disk. It is this thing. We also know that is xcm is integral of x dm over integral dm. This is how the center of mass is defined and how it is found out. Because ycm is going to be equal to 0, because we have taken the symmetrical axis, so that y is equal to 0, it is only the xcm we have to find out. So this is x dm over dm. Now instead of dm, what I put is pi y square dx into rho. We put the values. The rest is all simple, that if we just put the values, take the limits, and we will get the answer. So this becomes equal to pi y square dx rho into x. So we have y also, we have x also. So this is two kind of variables. What we do is we replace one by the other, because there is a relationship between the y and x. So because we are taking x as 0 to h and y is not a constant term, so we represent y in terms of x and we substitute it over here. That becomes r square by h square into x square. We put the value over here, dx rho dx. This comes out to be x cube dx. This is all constant, this comes out. So this is x cube dx, and in the denominator we know differential element of mass. If you add it, this is going to be total mass of this cone only. So over here in this step, what we have done is we have substituted rho density by mass per unit volume. Mass is m, volume is pi r square h by 3. We have put it. Now this is x cube. Integral is going to be x4 by 4, limits 0 to h. So this comes out to be 3 by h cube. This is, first we put this h upper limit into this, so h4 by 4 minus, then we put the lower limit minus 0, this comes out to be 3h by 4. Remember that this 3h by 4 is from this tip. From here, center of mass will be somewhere over here, that is 3h by 4 from here. If it is asked what is our distance from base, so total height is h, so h minus 3h by 4, that is h by 4 is the distance of the center of mass of this right circular solid cone from the base.